All right, this last video for 6.3 part 2 is going to be cos. So again, we're going to start with the same way we did sine and tan, even though we didn't do tan. And you're going to just type these in. So cos of 68 degrees is going to give us positive 0.3746. This is quadrant 1, so we're expecting to be positive. Now, if you don't want to touch your calculator again, we could look at the cast rule. In quadrant 2, I'm predicting that it's going to be negative 0.3746. In quadrant 3, I'm predicting that it's going to be negative 0.3746. And in quadrant 4, it's going to be positive 0.3746. If you're unsure, plug that into your calculator. Let's just plug in cos of 248. Oh, look at that, negative 0.3746. So the cast rule held true. Now we're going to again find theta. So to find theta, we're going to do the inverse cos of 0.3746. And when I plug this in, because this is a positive ratio, it's going to give my answer in the first quadrant. It's going to give me my reference angle. So if we go second function cos of 0.3746, I get 68 degrees. Awesome. Oh, look at that. I changed from one decimal place to whole number. It doesn't matter. Right? We'll just keep it this way. 68 degrees. Now let's plug it in of the negative. Now remember, sine and tan gave it in quadrant 4 red clockwise. But in quadrant 4, cosine is positive. So it can't give us this 292 red as negative 68. What's it going to give us? Well, let's just let the calculator tell us. So negative 0.3746. If I plug that in, I get inverse cos of negative 0.3746. It gives me 112 degrees. Well, that's interesting. So if I plug this one in, and I then wanted the answer in quadrant 3, well, how could I do that? This isn't a reference angle. So if you did it of the negative, you would have to then find the reference angle by going 180 minus 112 and getting 68 degrees. Whereas if you do it of the positive ratio, it just gives you the reference angle. So for a lot of these questions, even though they're asking you to find angle theta, they're not necessarily asking you for the answer that your calculator gives. Sometimes it could be this answer, sometimes it could be this answer. So this section is getting you to practice saying, hey, you know what? It really doesn't matter if it's positive 3.3746 or negative 0.3746. If I just want to find the angle in any quadrant, let's always find the reference angle, because then I can put it in any quadrant. And coming out of my mouth, that's sounding really confusing. So hopefully it's making sense to you. And if not, please come and ask me, or, make an appointment with me or anything, or go talk to your local center. But the key thing is don't get stuck on, just because the question says find angle theta, and I would do inverse cos of negative 0.3746, you might not always have to put that in. Sometimes you could put the positive ratio instead of the negative because you just want the reference angle. And that's weird, right? It's like not doing what the question told you to do, and yet it's going to get you the answer in an easier way. Or if what I'm saying makes no sense to you, feel free to do the inverse cos of the negative ratio, get that angle, and then have to find the reference angle, and then put it in the other quadrant. What am I talking about? Well, let's look at these two questions. So if the question said, cos theta equals positive 0.3746, and you wanted to give the answer in the interval 270 to 360, your calculator won't, right? If I type in inverse cos of 0.3746, we know that it's going to give us 68 degrees, right? It doesn't give us the answer in that interval. Our job is then to put it in that interval. Since I have the reference angle, to put this in quadrant 4, theta would be 360 minus 68, which would be 292 degrees. I always, in class, I will take the chance and not use a calculator. Here I'm like, let's just check. Awesome. So then if they ask you to find cos of theta, so theta, with the negative ratio, and then put it in the interval 180 to 270, again, I would ignore the negative. I would find the reference angle by doing inverse cos of 0.3746, because I know they all have the same reference angle of 68 degrees, and then I would put that in quadrant 3. If this is 68 degrees, theta would be 180 plus the 68, which would give you 248 degrees. Just double checking myself. I could just look above. And it's 248 degrees. So again, if you're like, but the calculator, I want to do what it says. Sure, put it in, negative 0.3746. But it's going to give you 112 degrees. It's not super helpful. You're then going to still have to find the reference angle to then put the answer in quadrant 3. So I recommend just ignore the negative with all of these questions, find the reference angle, and then put whatever quadrant you want to. So try this last one. Give the video a pause. First step, if you don't remember, you're simply going to say, okay, secant is the reciprocal of cos. So I'm going to write this as negative 1 over. For some reason, when I write decimals, I always switch my numbers around. 0, 4, 8, 5. Okay, so for me, I would find the reference angle by doing the inverse cos of what? I would do positive. I would ignore that negative because otherwise it's tricky. Okay, so to find the reference angle, I'm going to do inverse cos of bracket 1 divided by 1.0485. And maybe put a little x through the negative to remind yourself that you can ignore it. That gives me 17 degrees. And then it tells me quadrant 3. So if I want to have a reference angle of 17 degrees in quadrant 3, then theta would be 180 plus the 17, which would be 197 degrees. And again, if you want to totally ignore me because you're just like, I don't like that, if you were to do the inverse cos of negative 1 over 1.0485, what would you get? Well, you would do inverse cos, inverse cos, bracket 1 divided by negative 1.0485. And that gives me 163 degrees. Then I'd have to find the reference angle, right? The reference angle would be 180 minus the 163, which is still going to give you 17 degrees, and then you would put it in quadrant 3. So it's just quicker. If you ignore the negatives, you'll always get the reference angle, which you can then put in whatever quadrant you want. And that's true for sine, cosine, and tan. I did teach them separately only because cosine you kind of have to do this, whereas sine and tan, if you do it of the negative, you're getting the reference angle just read negatively, so it's not a big deal. But cosine, it matters just that little bit more.